Good day students. Here in this class we are going to discuss about the present value of an annuity. In my previous class I taught you how to calculate the total amount of your annuity. Here capital P is nothing but present value of your future amount A for the rate of interest I, which is compounded annually. And the formula to calculate your present value is P is equal to A divided by I into 1 minus 1 divided by 1 plus I the whole power n. And the present value of perpetuity is calculated by P is equal to A divided by I. Similarly, the present value for annuity deferred for D years and present value for perpetuity deferred for D years is given here. Let me go straight away to problem. In problem 1, what the thing given is, a man wishes to make lump sum deposit of an amount which provide payment of 1000 a year. 5 withdrawals of rupees 1000 will be made, first taking place one after the account was opened. What should be the amount invested if the interest is 6% compounded annually and the account has to be exhausted in 5 withdrawals? So, we need to find a lump sum amount which is to be deposited now to get a periodic payments of rupees 1000 for 5 withdrawals at a rate of 6% compound interest. So, we need to find the value for P, provided the value for A is given as 1000 rupees, N is 5 and the value for I is 0.06 as it is given as 6% compounded annually. The formula to calculate perpetuity is P is equal to A divided by I into 1 minus 1 divided by 1 plus I the whole power n. So replace all the values, we will be getting our required result. 1000 divided by 0.06, 1 minus 1 divided by 1.06 to the power n, the value for n is 5. Make use of your calculator. The value for 1.06 to the power 5 is 1.338. So 1000 divided by 0.06 into 1 minus 1 divided by 1.338. Now calculate the value which is inside your bracket. 1 divided by 1.338. You will be getting 0.747. So 1000 divided by 0.06 into 1 minus 0.747. Sorry. Yes. So now calculate the value for this. 1 minus 0.747, you will be getting 0.253. Apply the same with 1000, you are getting 253. Divide with 0.06, you are getting 4216 rupees as your answer. So the answer is rupees 4216.67. There will be some minor change in your decimal value because we are truncating here. Second problem under perpetuity. A man borrows rupees 1500 and agrees to repay the debt by 5 equal installments by 5 equal annual payments with 6% interest compounded annually. If the first payment is to be made at the end of the first year, how much should each payment be? So here it is given as the amount a person buys is nothing but rupees 1500 and he is going to repay this 1500 in 5 equal installments. As this is your bulk amount, the value for P is nothing but rupees 1500. As he is going to repay the amount in 5 equal installments, the value for n is 5 and the value for I is 0.06. So we need to find the value for A. How much should he pay? Should each payment be? Okay. So the same formula, P is equal to A divided by I into 1 minus 1 divided by 1 plus I the whole power n. So the value for P is 1500. That will be equal to A divided by 0.06 into 1 minus 1 divided by 1.06 to the power 5. As we need to find the value for A, take this to the other side. 1500 into 0.06 divided by 1 divided by 1 minus 1 divided by 1.06 to the power 5. So when you calculate the value for this, you will be getting 356 rupees approximately. So on paying an amount of 356 for as 5 equal installments, he can able to repay the debt of rupees 1500 which he borrows. The last sum. Find the present value of deferred annuity of rupees 2000 per year if the first payment begins at the end of 5 years and it will continue for 12 years for 5% compound interest. So here in the question it is given as deferred annuity and the first payment will begin after 5 years. So we need to calculate the value for deferred annuity. Deferred annuity. So the formula is P is equal to 1 divided by 1 plus I the whole power d into A divided by I 1 minus 1 divided by 1 plus I the whole power n. Here this is nothing but the value for your d, this is the value for your A, and the value for n is 12 years at the rate of compound interest R as 5%. So the value for I will be 0.05. Replace everything in the formula. 1 divided by 1.05 to the power d. The value for d is 5 into A divided by I. So 2000 divided by I. The value for I is 0.05 into 1 minus 1 divided by 1.05 to the power n. The value for n is 12. So make use of your calculator to find the answer. 1 divided by 1.05 to the power 5 into 2000 divided by 0.05 into what it is. 1 divided by 1.05 to the power 12. It is 0.557. 1 minus 0.557. In the same way, calculate the part here. So 2000 divided by 1.05 to the power 5 into 0.5. 2000 divided by, let me open a bracket as there are two terms. 1.05 to the power 5 into 0.05. Close the bracket. So you are getting 31,341. 31,341. And this need to be multiplied by 1 minus 0.557. 1 minus 0.557, it is 0.443. So when you multiply these two, 31341 into 0.443. So that will give you 13,884.063. 13,884.063 as your answer.